My name is Janos and I will talk about benchmark RESPLE to HDMapping. So let's click this link. Let's follow the hint. Please change branch. So we click this branch, our favorite branch, with our bunker dataset. So we have downloaded this data, so now we can use these commands and this tool that we already downloaded. So we just open the terminal and we just follow the instructions. So we prepared our data. We have to convert twice. This is the easiest way. Maybe you can find better one, but we propose this one. It is tested, so yeah. Okay, so we are waiting for the data processing. So what we do, we convert data from one back to HDMapping, and then from HDMapping to ROS1. Okay, conversion is successfully. So now we have the second conversion. We should have this file that it's supposed to be here. So let's try to find it. So we have HDMapping benchmark data, and supposed to be somewhere here. And this is our input file. The reg1 res2 LiDAR is output. This one. Oh, no, not this one. Where is this file? File ROS1, ROS2 LiDAR. Okay, let's follow. I hope everything is okay. So run following commands. Let's go here. We go here. Then we clone RESPLE. It's quite a huge project because it is cloning quite long. So if it is big, it should work very good, I hope. Okay, so we go there. We go to our favorite branch and we build Docker. Okay, everything is built. So let's run this one. Let's run our Docker, and then let's go to the data and then convert. You can see that we have plenty of data conventions. I hope you can send me some information how to make it much easier. I'll be very happy to simplify the process. So it is still converting. So during the conversion, let's check what we have in this, where to find information about this method, RESPLE method. So if you go to our website and if you find the RESPLE, then you can easily click RESPLE, and then you have this fantastic tool here, so you can see how to run it, and you can enjoy it from this GitHub. Okay, so we have it already, and now we close the terminal, we open new terminal, and we follow instructions. So we follow this instruction, we change some accesses to the files. Okay, and finally we run the system. Oh, it is nice, showing something. Let's wait a little. So let's check what we have in our dataset. So let's see the dataset here on the left side. Oh, it is very nice. It looks very nice because we have very dense information. It is very promising. It's very promising. It gives very dense information and looks fantastic. So let's wait a moment. So what about the dataset? Dataset is made by our colleagues from Royal Military Academy of Belgium and Ghent University, and this dataset is about collecting data with this device, that it is 3D LiDAR, active stereo camera, passive stereo camera, time of flight camera, and multiple inertial measurement units. It is a fantastic toy. It's not professional equipment, sorry for that comment. This professional equipment is acquiring data in this environment that, in my opinion, it is very interesting because it is composed of plenty of tiny spaces, and you have different illumination, you have different situation inside, so you can test your system how it works in such conditions. So you can see, for example, now, it is very nice moment that you have very tiny space, and you can see here that this algorithm has some issues. So you can see that the algorithm is struggling with recovering a correct trajectory. But let's continue. Let's hope it can work. We will evaluate later on, but for now it is important to see how it performs. So maybe we should have some recovery procedure, but we don't have it now. Okay, let's continue. So, a short story about our project. So, our project, the goal of our project is mentioned here in the beginning. So, the goal, where is the goal? Yeah, the goal is to find, develop, discover best end-to-end mobile mapping framework. So we are focused on the best one. We are focused on looking for or developing or to make best mobile mapping system, and this mobile mapping system supposed to make maps of entire cities. We would like to use any LiDAR, any 3D LiDAR you can find, and we would like to create maps of entire cities, and we can do that. We claim that we can do maps at this moment, but the process is not yet optimized and not yet automatic. still human in the loop, so you should make a map by your own. Sometimes you have to make it manually, like loop closures, but it can give you opportunity, this project give you opportunity that you can create such big maps. These are some systems that we have already tested, and you have plenty of movies. I have to update them. And what I would like to tell today is that we extend the family of supported operating systems to macOS. So we'll have Windows, Linux, and macOS. Okay, I think we are going to the end of this data set. We are going back, and I hope everything will be okay. But you can see the algorithm is struggling because it has plenty of false positives. So I don't know if I can tell false positives. Let's say the map is not correct, so it cannot recover trajectory. But once it recovers somehow, it can work very well. So you can see this dataset is very challenging because it has plenty of narrow spaces that makes challenge. You can see trespassing from narrow doors and so on, like here. It's not easy. Most of the algorithms we observed, they are designed for open spaces, like for autonomous cars and so on, but they are struggling with such environments. Okay, so I think we are waiting now for data, and now we have this data, so let's find them. Somewhere. So we have this RESPLE. Where is it? This RESPLE. This one. So we are looking for this session JSON. So we will open our software, multi-view TLS registration step second, and we open this RESPLE session. This is our session. Let's make much more points to show, and let's export scan as a global scan. So we have it here. So where is RESPLE here? So we will have all pc.laz, and we can save trajectory as an XYZ and quaternion, like sometimes we call it TOM format, thanks to our colleagues who start evaluation of trajectories. Okay, so we have this output RESPLE, and we find trajectory all.csv. So let's open Cloud Compare. Cloud Compare, and let's see what we have from our data. Okay, so we have this one, and we can drag and drop our map, and we can drag and drop our trajectory, and you have X, Y, Z and quaternion, so you apply all, and you have everything for evaluation. So you can see that partially this algorithm is very promising. Unfortunately, there are some places that it fails, so this significant failure can affect your map. This is the trajectory, and I would like to thank you for watching and see you soon.